AI chatbots are getting smarter every day, but here's the catch. Every time you ask them something, they light up their entire digital brain, like flipping on every light in a skyscraper just to find your car keys. It works, but it's insanely wasteful. Tons of electricity, time, and money down the drain. Now, Microsoft and a group of researchers may have finally cracked the code. They figured out how to make the AI models behave more like human brains, only using the neurons that actually matter, and they did it without retraining anything. They did it using something quite secret that we will get to later on in the video. Let's break it down. Large language models, those chatty AIs with billions of internal dials, normally light up almost every neuron in their brain just to answer one simple question. That means tons of math, huge power costs, and slower replies. Imagine turning on all 20 floors of an office building just to grab a paperclip. It works, but it's far from efficient. Engineers have tried two main ways to fix this. First, there's the mixture of experts trick. Picture a big team of specialists, grammar whiz, science nerd, trivia champ, and the model learns to only call the one it needs. Great idea, but training that expert team takes time and effort. If you're a company just using an off-the-shelf model, retraining isn't ideal. Second, there's the training fee method. No extra learning, just shut off neurons while the model runs. Methods like teal and cats do this by measuring how loud each neuron is. Quiet ones get muted, simple in theory, until you make the wrong ones. Some neurons are quiet but critical, others are loud and useless, so performance takes a hit. Enter WINA, short for Weight-Informed Neuron Activation. It's the work of a joint team from Microsoft, Renmin University, NYU, and South China University of Tech. They dropped the full academic paper on May 29, 2025, and a more readable summary a couple days later. WINA's twist is surprisingly simple. Don't just measure how loud a neuron is. Also look at how amplified its signal is by the weights it passes through. Basically, how big a megaphone it's holding. Here's the plain English. A neuron sends a signal. That signal gets multiplied by a bunch of weights. Some boost it, some barely affect it. WINA multiplies the neuron's volume by the strength of its weights, and only keeps the ones with the biggest combined effect. The rest, they take a nap. And just like that, the model can shut off way more of itself without losing quality of answers. Now, smart folks might ask, what if the weights are messy or skewed? Won't that mess up the rankings? The researchers thought of that. They apply a cleanup step using something called singular value decomposition. Basically, rotating the math furniture so everything's lined up nicely. That way, the math stays clean and the error stays low. So how well does it work? They tested WINA on 4 major models: QWEN 2.57b, LLAMA 2.7b, LLAMA 3.8b, and FI4 14b. Those 7b and 14 numbers, that's how many parameters, aka dials, the model has. To test accuracy, they ran 6 public benchmark quizzes like PIQA for physical reasoning, GS M8K for grade school math, MMLU for general knowledge. The results? Impressive. When they shut off 65% of the neurons, nearly 2/3, WINA still beat teal by almost 3 points on QWEN and about 2 points on FI4. On LLAMA3, WINA pulled ahead by 1 to 2 points past the halfway mark. That might sound small, but in machine learning, a single decimal matters. A 2-point lead? That's like crushing your marathon time by 5 minutes. And it's not just accuracy, it's speed too. WINA cut down the raw competition, measured in flops, floating point operations. On QWEN 2.5, flops dropped from 7 billion to just 2.8 billion. LLAMA2 went from 6.6 down to 2.4. That's a nearly 60% cut. Same answers, way less power. Translation? If you're running this in a data center, it's half the GPU bill. Not bad. And the best part? No retraining needed. You just plug WINA into a model that you already have, set how aggressive you want it to be, say 25%, 50%, or 65% neuron cutoff, and that's it. You can even tweak the percentage per layer if needed. A small greedy algorithm borrowed from teal helps balance everything. Now, one technical wrinkle. WINA's math assumes the model's weights are column orthogonal. Fancy way of saying the weights don't overlap too much. Real models rarely meet that condition perfectly, so WINA automatically applies that same rotate the furniture transformation to enforce near orthogonality only where it matters. End result, predictions stay identical when no neurons are gated. And once the safety check passes, you can start trimming flops. If you're the math-loving type, the paper backs all this up. Lemma 3.1 shows WINA's error is always smaller than teal's in a single layer. Theorems 3.2 and 3.5 extended that across the whole model, even though nonlinear activation functions like ReLU, SILU, and softmax. Also worth noting, WINA isn't just pruning. Pruning deletes neurons for good. and usually needs retraining to recover lost accuracy. WINA is dynamic. Neurons stay intact and take naps only when needed. It's flexible. You can turn off more neurons for easy prompts and back off for harder ones. Before we wrap, 2 cool extras. Microsoft has open sourced the code under Microsoft WINA on GitHub, so you can try it today. They are also co-hosting an online AI infrastructure mini-conference on August 2nd, 2025, and they're actively looking for speakers. This isn't some massive mega event where you need a PhD and a 200 slide deck. It's a focused, nerd-friendly gathering for folks working on the nuts and bolts of making AI run cheaper, faster, and smarter. So if you're a dev, engineer, or a curious hacker, and you try WINA on your own model and manage to cut inference costs, speed things up, or even just replicate the results, you've basically got a ready-made talk. No need to invent something from scratch. Share your setup, your benchmarks, and take on how it went. Seriously, this is the kind of conference where real-world stories matter more than glossy presentations. They want hands-on insights, even if it's just, we tried this on our chatbot serving 100k users and dropped the GPU usage by 40%. That's gold. It's a chance to get your name in the mix, connect with other infra folks, and maybe even influence the next round of research directions. So yeah, if WINA helps your project, don't just pat yourself on the back. Submit a talk proposal. You've got until July. They also shout for Parlin, an open source toolkit for monitoring how chatbots behave in customer service. Faster inference means cheaper fine-tuning and alignment, so the connection makes sense. Final thoughts? WINA gives you a simple logic tweak. Multiply activation size by weight, strength, keep only the biggest players, and do a bit of matrix cleanup to keep the math clean. That's it. You get up to 60+% less compute, stay more accurate than Teal, and you don't have to train a thing. It's maybe the easiest AI infra in 2025. But here's the kicker. If we shut off most of the AI's brain and still get the smarter answers, what exactly have we been spending billions on all this time? Drop your thoughts in the comments, hit subscribe if you like this kind of deep dive madness, and smash that like button if your GPU deserves a break. Catch you in the next one.